Today we are going to go through again kinematics of particles. So this is the last topic of kinematics of particles. We are going to be done today the kinematics, and we are going to go through the kinetics of the body in dynamics class. So let's go through all this chapter, the first chapter's subject, and finish up. Then we will be ready for kinetics part. In this topic is the next one is the absolute dependence motion, which is analysis of two particles, which is relative, almost relative motions, which we will see next topic or subtopic of this class. Absolute dependent motion analysis of two particles. Let's define it. In some types of problems, the motion of one particle will depend on the corresponding motion of another particles, like this guy, right? This is that we have a pulley system. If we pull the block B to the down, we will see the block A is dependent on B. How much we pull is gonna be A is gonna be pushed up. So it's dependent, right? So it's absolute dependent motion. This dependency commonly occurs if the particles, here represented by blocks, are interconnected by inextensible cords which are wrapped around pulleys. So this is the pulley, and this is the inextendable cord, which it's not going to be extended, and we will not do elasticity of this cord. Just is going to be rigid. So how much we pull B or how much we pull A is going to be reflect to the other blocks. So position coordinates SA and SB, which is the position of S and the block A and block B when it changed. Each coordinates axis is measured from a fixed point O or fixed datum line, which is datum is, we can take it like we can say, okay, from C to D is not gonna be changed, is gonna be fixed, so you can take it out. So this is our datum and this is our datum. We can then till the course end, and measured along each inclined plane in the direction of motion of each block, and has a positive sense from the fixed datums to A and to B. If the total chord length is IT, the two position coordinates are related by the equation of, so let's say if we have SA plus ICD, which is the CD on the pulley's length arcs, let's say pulley's arcs from C to D, if you add, and plus SB is gonna be the total chord, right, which is IT. So let's say here SA from this point to this point is then the chord's length of SA on the pulley, which is like wrapped by the on the pulley, is gonna be an arc of CD, which is we are gonna show ICD, plus SB, which is from this datum to the blocks B, is gonna be SB and is equal to IT. Okay, this is the our equation for the displacement, right? So we just set it up this equation. If we take, we know that if we take the displacement's derivative with respect to time, is gonna be the velocity. So if I take this, if I pull, we know that if I pull, this guy is gonna change, right? So with respect to time, SA is gonna be decreased, SP is gonna be increased. So there's gonna be change with time. All right, let's take the derivative, as I said, dSA dt. And plus dsb dt is equal to 0. Why? Because this CD with respect to time is not gonna change. It's gonna be the same all the time, even though like as a comes to the 0 and SP is along with the IT minus ICD, which is the total length minus the Polish arc, doesn't matter. ICD is gonna be constant, and total length of the poly, the chord, is gonna be constant. If you take the first derivative, is gonna go to 0. So the derivative of this guy is gonna be 0. Derivative of this guy is gonna be 0. So we will have the velocity of A plus velocity of B is gonna be equal to 0, which means velocity A is equal to minus velocity of A, which is, if I pull the block B in the negative direction, on the downside, block A is gonna go to upside, so it's gonna be positive direction. So it's gonna be like opposite directions to each other. Same thing, if I take the double derivative of the time, is gonna be the same thing, like AB acceleration in the B is equal to minus acceleration of position in the blocks of A's acceleration in the negative direction. It's really simple as it is. We remember in our physics 1 class, so I am not gonna go, also in the high school class of course, so I'm not gonna go through the detail, but let me show the one very simple example here. What we need to do, like if we have this kind of pulley system with connected to a block A, and B is gonna be dependent, as we will see. So we need to take always the datum, but we need to choose where we need to take the datum, and where we can make it the above this datum is gonna be ignored. As you see, this poly is stuck with here and is fixed, so this chord never change, right? This poly is not gonna go down or up, it's fixed. This guy here, if we pull it down here, is gonna be come till here, down up on this line. So this length is gonna be go around this poly, this one, so it's gonna be the same as in this line, right? So if I take the datum over here, I can cancel. I will not put these two guys into the equation. All right, after that, let's set up our equation. I will say, if I put from here to this line, because I know that this I in this line is red line is gonna be constant, so I don't need to plug this guy. So 1, 2 of SB plus this hash from this guy to here, hash, plus SA, which is from this line, this datum to the end, is equal to total length of the chord, which is changing the position, which is changing hash, SB and SA. It can be changed inside, but I or L, let's say, is gonna be constant all the time. It's because it's the total length of changeable interchangeable chord. Okay, L and H are constant during the motion. As you see, this is also due to this poly is constant over here, and this poly is gonna be constant here, so this H is gonna be constant as well. So we can take it out, this guy, if we take the derivative. Okay, is gonna be, if I want to take the derivative and then find the velocity, 2vb is equal to minus va, or 2ab is equal to minus aa. We can find it very easily. So in this question, or in this example, the main thing is where we are gonna take the datum, okay? And also we are gonna take, after this point, we are gonna take the cancel or neglect these arcs all the time, here, 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 because it's constant. So it's not important to put every time you are gonna take it out. All right. Hence, when B moves downward, right? When B moves downward, what is gonna be? A moves to the left minus SA with twice the motion. Okay. So you are gonna take it into account, like, because if here is the, like, is showing negative, because it's not pulling, or it's gonna be pushing to each other, so there's an opposite direction motion. Therefore we are showing this minus sign. So you guys need to focus when you see this kind of problems. When you pull this one down, what is happening? When you pull, is gonna be, this guy is gonna be towards to each other, right? It's not gonna go to both of them in positive direction. Okay, let's solve like couple examples in order to understand better these Pauli systems and absolute dependent motion. Okay, if we have this kind of question, let's see first of all the question. In the figure, the chord at A is pulled down with a speed of 2 meters per second. All right, and the question is asking, find the speed of block B. So it's very simple. So if we pull this pulley and the cord with 2 meters per second velocity, what is the B is going to upward, right? As we see, when you pull down, this guy is gonna go up. So this pull is up. So that guy is gonna go up as well. First of all, let's draw the datum. As we see here is constant. If we bring this pulley to the here, it's gonna be somewhere here, and then these three pulleys, but these two pulleys is gonna be the same horizontal level. So we can take the datum line here, so we can cancel these guys, this length of cord and this length of the cord. So we can just consume, and we will take it out these guys and this length too and this length too, right? So these the cords cover wrapped on the pulley is also ignored. Then we can we have the first chord and second chord. There are two different chords, so we can write for chord 1 and one equation, which is, if I take it from here, we can say for SA plus 2SC is gonna be length of the first chord. You know that is like SC from 1 to
and SA to here, point A. So SA, which is the length of A, is equal plus 2SC, which is here for the C chords, is gonna be equal to the first chord length, right? This one. Then when we go to chord 2, we need to write another equation. For the second chord, we can say we have this length, which is, we can say this is SP here. The datum is SP. So we have SP plus SP minus SC, which is here, right? So I can say SP plus SP minus SC is gonna give us the length, the second chord length, which is length 2. From here we can connect these two and we can eliminate SC because it's the intermediate length of this chord. But I want to know from SA to SP the relationship between A to B. So if I added, I'm not gonna do these quadratic equations and like the simple linear equations. You guys are gonna solve it. Is gonna be SA plus 4SB is equal to L1 plus L2. You know, from this one, if I want to cancel, I need to multiply by 2 everywhere. So it's very obvious. L1 plus 2L2. SA is gonna be here. This guy is gonna cancel this guy, and here we have 2SP, so it's gonna be 4SP. So this is our equation of for the chords. So if I take the derivative, we will see that VA plus 4VB is equal to 0, right? Because the length of these guys is cancelled. So it's gonna be 0. And if I know from here VA is 2, we know that VA is 2 meters per second. So if I plug over here, I can see VB is minus 0.5 meters per second. So is the opposite side of the poly of this VA, right? Because I made it the position to the down is positive. That's why I put 2 meters per second here. So it's gonna be negative side. So it's gonna be upside. To the upside is gonna be our minus side. So we will see very easily how it's gonna be the block speed velocity. In the second question, let's write it down again. Our question: the rope is drawn downward. Drawn towards to motor M at a speed of 5t power of parenthesis 3/2 meter per second, where t is in seconds. We are gonna find the speed of block A when t is equal to 10 seconds. Let's investigate in our question. So the rope is pulling downward to the here on the motor towards the motor. Okay, so the rope is taken by inside the wrapped in on this pulley by the motor. What happened? Like as you see, when it's pulled down, this guy is gonna go up. So our block A is gonna go up, and it's asking if t is equal to 10 seconds. The speed of A is block A is what is the block's A velocity, and we can know because the rope is pulling by 5d square power of 3 over 2, so we can say the velocity of this point, as we choose this point in the question is also given 5t power of 3 over 2. So let's choose our datum line. As you see here, this is constant, so we can say here is our datum line, right? And we, as we always say, wrapped the cord around the pulleys are constant. And where can we say is constant as well? This guy and this guy is constant, is not moving, is fixed, right? So we can say also till like here. So it's gonna be here is constant. Let's say is another datum line. But this we choose this red point because this red point is moving downward toward the this motor. That's why we are choosing this rope is mobile. This point is mobile. This rope is also constant. If we take this one constant 0, then we cannot solve this question. That's why we are gonna put a point of somewhere on this rope. Then we are gonna try to solve this question. So okay, let's set up our equation. Okay, first of all, let's define again our rope place, the distance from here to here. Let's say we have a rope of distance SA, right? Because here is constant, it doesn't change. The wrapped area doesn't change, but here is changing, the distance is changing. So I can say the 1, 2, 3 SA, and from here to here, let's say till down, when we move, so SM. Then I can set up the equation 1, 2, 3 PSA plus SM is equal to the length of from here to here, right? So it starts from here, this length, until here. So is a length L. If I take the first derivative, it's gonna be 3 VA. The block A is moving with 3 times plus the motor's chain holding Vm is equal to 0. So we set up our velocity equation as well. So what do we need? We know that the velocity m is 5t power of 3 over 2. So 3 VA plus 5t power of 3 over 2 is equal to 0. So velocity of A is 5/3 t power of 3/2. So we know that at t is equal to 10 seconds. We just plug instead of t 10. Velocity of A is 5/3 10 to power 3/2, which is gonna be is equal to okay, hold on just a second. It's gonna be this guy is gonna be minus, right? Yes, this guy is gonna be minus, and it's gonna be minus I think hold on a second, let me calculate it. Alright, it is minus 52.7 meter per second is block A on the upside. Is going to upside, as I said, but with 52.7 meter per second. I think that's it for this question. Okay, when we come to the last question for the Poly system, let's write it down the question. In this Poly system, block A is moving downward with a speed of 4 feet per second. While block C is moving up at 2 feet per second. Find the speed of block B. Okay, as we say, is this Poly system, block A is moving downward. Where is it? Here, it's going downward with 4 feet per second, while the block C is moving up at 2 feet per second. So I'm asking block B, what is the speed of block B? Okay, it's on you. So your quiz is this one. Write it down and I'll send it to my box. Then we can continue the question.
The last subsection is relative motion of two particles using translating axis. Throughout this chapter, the absolute motion of a particle has been determined using a single fixed reference time. There are many cases, however, where the path of motion for a particle is complicated, so that it may be easier to analyze the motion in parts by using two or more frames of references. In this section, translating frames of reference will be considered for the analysis. we are gonna see what is the translating frames of reference, then how we are gonna solve this relative motion. Okay, in this relative motion, let's have an fixed observer in fixed point O, and in the Cartesian coordinate z-axis, y-axis, and x-axis. And we have two particles. Let's say we have a B and A, which is a distance of RA, a vector form, and RB. So, and the differences is RB minus RA, right? Or which we say B with respect to A. So it's differences. In this frame references, the idea is let's move this fixed observer to the translating to the A, and then look at the B, so how it will behave. So, and then you are bringing these guys instead of X, Y, Z. You are saying, okay, I'm making Z prime, X prime, and X prime, and Y prime. And let's calculate it in this way. By the time you are saying, okay, if I want to calculate the position of B, we know that in the vectoral form, RB is equal to RA plus RBA, right? RA plus RBA is gonna give us total of RB, which is from fixed point to point B when it translates. Okay, let's go through to understand better what I mean by changing the reference of frames. So when we have RB with respect to A and RBA, it means RA with respect to B, and if I take the first derivative of both, so I will have VB, the velocity of B, is equal to drB dt. We know that, and VA dr dt, this is absolute velocities, and B, the velocity of B is equal to velocity of A plus B with respect to A, which is relative velocity. So what we are doing, absolute velocity plus relative velocity is giving us the frame B, or the position B. So x prime, y prime, z prime axis translate the components of RB versus of A will not change direction, and therefore the time derivative of these components will only not have to account for the change their magnitudes. So it's not gonna it's obvious that like it's not gonna change its magnitude. Let's jump to another subject. Hold on, which is the acceleration. So it's similar with the velocity. AB, the acceleration of B, is equal to acceleration of A plus acceleration of A with respect to B. Here A with respect to A is the acceleration of B as seen by the observer located at A. So if you have here and you are seeing the B, how it's accelerated by locating here, okay? But the other one is acceleration of A, how is accelerate, and acceleration of B is also accelerate, right? And B, when we see from the A, so acceleration of B with respect to A is gonna give us the relation between this motion. So we have this three equation, which is if I want to find the position of B, I need to calculate it position of A, if I know position of A, and then if I know position of B with respect to A, I can find the absolute position of B. Same thing as velocity, same thing for acceleration. So if I know absolute values of absolute velocity or absolute acceleration of A, and if I know the from the translating observer frame to this guy, or vice versa, if I know the absolute velocity of B and absolute velocity of A, then I can find the relative velocities between these two particles. And also we need to remind that if we change the coordinate system, we have the normal acceleration. If it is curvilinear motion, we have the normal acceleration, which is translational velocity square over the radius of curvature. We need to remind this one if the motion is here the curvilinear.
All right. For the first example, for the relative motion, a train travels at constant speed of 60 miles per hour. 60 miles per hour, and crosses over a road as shown. If the automobile A is traveling at 45 miles per hour along the road, we will determine the magnitude and direction of the velocity of the train relative to the automobile. Okay, let's put this guy here, let's push here. Okay, the train is passing through this bridge with 60 miles per hour, and then the road passing over this bridge, under the bridge, and the automobile going 45 miles per hour, and with each other with 45 degrees. This road has 45 degrees with horizontal, so we need to take into account this one as well, because we are gonna go through the two-dimensional x and y, and we are gonna compare with this, and what we are gonna find the magnitude and the direction of the velocity of the train relative to the automobile, not the fixed point. We are right now looking for the relative to the automobile, because if it is fixed points, we know that it is in x direction, so positive x direction is going to be 16I, we are going to say, and if the automobile is going to be 45, we are going to divide it in square root 2 over 2, and we will find 45 multiplied by square root 2 over 2 to find x and y directions, x and like I and j velocity. But we are gonna see right now into we are gonna fix reference of frame right on the automobile, and then we are gonna see the train. We are gonna find the train's velocity. Okay, let's try to solve. First of all, let's try to remember what is the train velocity relative to the automobile, which we are gonna say we train with respect to t over a, right? And then if we want to set up the equation, we know that the train velocity is equal to automobile velocity plus the train velocity with respect to automobile. We want to find the train velocity with respect to automobile, so that means we train velocity with respect to relative to the automobile is equal to train velocity minus automobile velocity. Okay, let's define our train velocity and automobile velocity. The train velocity, as I said, is gonna be a positive x direction, which is 60 I in vectoral form, mile per hour, right? Mile per hour. And then the automobile velocity is, we can solve it, 45. The magnitude is a 45. What we need to do in the x direction, what we need to do if we have a vector in this direction, if we multiply cosine 45 is gonna be x direction, right? So cosine 45 I, which is positive direction as well, and j is also in positive direction, so I'm gonna multiply, I'm gonna put in positive sign, sine 45 j is gonna give us y direction velocity. Okay, if we plug in this equation, v t over a is equal to 60, and then we are gonna put minus, right? Minus 45 cosine 45. This is regrouped in x direction, which is positive x direction. So we are gonna say is I. Then we are gonna say plus, there is no j direction here. Okay, then it's gonna be just minus, because we are gonna put minus a, so minus 45 sine 45 sine 45. So it's gonna be, this one is in j. Okay, so let's little bit make a space. If we solve this guy, then we can have the train velocity with respect to a, which is automobile, is gonna be 60 minus 45 multiplied by 45 is gonna be 28.2 I, and minus 45 sine 45 is 31.8 j is gonna be our VTA in vectoral form. So if we want to find the magnitude, the train relative to automobile, is what we need to do, square root of 28.2 square plus minus 31.8 square, total of square root of these guys. Let me calculate and come back. Okay, when we calculate, it's gonna be 42.5 mile per hour is gonna be our train velocity relative to automobile. And direction, how we are gonna find the direction, as you remember from physics class or statics class, if we have this kind of vectoral form, right? What we were doing is we were saying tangent theta is, what was the tangent theta? Y over x, right? So y is minus 31.8 and x is 28.2. So if we want to find the theta, is gonna be arctangent of these guys. So let's find theta. Theta is tangent minus 1, tangent minus 1, and this term is 30 minus 31.8 over 28.2. Let me calculate as this one again, and then let me write the solution. So it's minus 48.4. So if it is in horizontal line, if it is minus, so it's gonna be something like this, which is 48.4. So the train sees automobile in going this direction. All right. Today's last question is, let's write it down. Cars A and B are traveling with speed of 18 meter per second, and 12 meter per second, respectively. All right. Also, at this point, A has decrease in speed of 2 meter per second square, decrease in speed of 2 meter per second square, and B has an increase in speed of 3 meter per second square. We will determine the velocity and acceleration of B with respect to A. Okay, let's put these guys here. Let's extend it this guy. Sorry. Okay. So okay, we have A and B. A is going into horizontally 60 degrees upward, and the B is moving from the curvilinear motion to the rectilinear motion. So let's say that as soon as it reach this curved path, it reached to the straight path, but still is continued in curvilinear motion. So we need to take care of this curvilinear motion as well. What we need to know, we are gonna determine the acceleration and velocity of B with respect to A. So what we need to know, VB with respect to A, right? We know that with this one, then we said this guy is VB minus VA in the vectoral form, right? We already defined this guy. So let's plug this VB, which is this guy, right? B is this guy. So it is minus 12J, right? Is going into the downward side. So it's gonna be minus 12J is gonna be my B velocity in the downward side, because it approached right now here, then it goes to minus side. Sorry, this is for B. I'm trying to find V B over A, which is the automobile by B with respect to A. So first of all, I need to write minus 12J for this term. Then after that, I'm gonna write it down. Let's see J minus. Then we are gonna write A, which is the velocity is in the negative direction, right? Minus 18, 18 meter per second square. So it's gonna be in the minus x direction as well. So I'm gonna say minus 18 minus 18 minus 18 cosine 60 cosine 60, which is this one is I, and then it's going also the minus j direction, so it's gonna be minus 18. This one is sinus 60 sinus 60 in j, right? So think about this guy is like here, right? Is going in this direction, but in the negative direction. So when we say cosine is going to x direction, when we say sine is going to be again in the minus direction. So if we plug these terms, we will find VBA as VBA is equal to 9i 9i and plus 3 point 3.588J 588J. So VB with respect to A in vectorial form is 9i plus 3.588J. Okay. If we want to find the magnitude of this velocity, so VBA is gonna be, as we know, that is square root of 9 square plus 3.588 square over square root. This is equal to 9.69 meter per second. 9.69 meter per second speed of the automobile B with respect to A. Then let's go to second part. If you want to know the acceleration is the same thing. A B with respect to A is equal to AB minus AA, right? It's gonna be the same thing as previous one. So let's define how we are gonna calculate these guys. Hold on a second first. Let's take the picture. Let me tell you on the picture. So for the acceleration for car A is given 2 meters per second square, and it's rectilinear motion, so we can divide it into components and then we can solve it. But for car B, as I said, is curved path. Yeah, like in J direction, it's given like 3 meters per second in going downward side, so it's increasing. But also due to the curve path, when it comes, there is a centripetal motion. So we need to multiply this 12 meters per second, the velocity square over the radius of curvature, which is 12 square is 144, and over 100 meter is gonna be 1.44, but in negative I direction. So we need to know this guy. Then after that we have to solve the question. Let's go back our term. As we said, for B, we can say minus 1.44 I, because it's going to minus direction. Then we have minus J direction is 3 meter per second square. Then we have these B terms. Then we are gonna add the A terms. A terms is we have 2 cosine 60 is in the I direction, right? In I direction. Then we have also 2 sine 60 in J direction, because it was both of them in positive direction. Okay, so when we add each other, we are gonna have B with respect to A, the acceleration B with respect to A is minus 2.44 I in I direction, and minus 4.73 in J direction, which is the unit of meter per second square in the vector of. So this is how the automobile B is seeing the automobile A, like with respect to automobile A. Like A is seeing the, because we are taking the A as a reference of frame, and then we are calculating the B, automobile B acceleration. All right, that's it. Thank you for listening.